Dr. T.V. Geeta, Professor, Department of Computer Science, College of Engineering, Guindy, Anna University. Her special interest, Artificial Intelligence and Natural Language. She has published more than 143 articles in national and international journals. She has guided around 7 PhD students. She has got Young Scientist Award from Government of Tamil Nadu in the year 2000, Chief Minister's Special Mention Award in the year 2002, and Woman of Excellence by Rotary Club in the year 2003.
Welcome to the UGC lecture series. In this lecture, we are going to continue with the introduction to the databases. So, again we are going to look through some of the other issues, the issues that we have already discussed, some more issues on the need for database management system against a file based system. Then we are going to look at define a database and define a database management system from different perspectives, and then we are going to look at exactly what are the objectives of a database management system. So, we were discussing some issues in the last lecture, so we continue with the issues here. So, suppose you have multiple updates on a all or none basis, that is two household merge, then this requires changing the addresses of, remember we are still talking about the address list where we had names and addresses. So, we are talking about changing the address of several persons. Now, we are bringing in a new problem. Now, at this stage, suppose in the middle of the update the computer crashes, then what happens? You will have inconsistent information. So, you have to give the solution to this is you have to give an illusion to the user that all updates, database user, that all updates are occurring simultaneously, while actually it is not occurring simultaneously. So, what do you do? Now comes the concept of commit or rollback of the entire piece of work. What do we mean by this is that if in the middle of an update the system crashes, then you have to roll back to before the update actually happened, that is the whole transaction, it is called an entire piece of work. Or if the complete update is over, you have to commit. So, you do not commit unless the complete thing is over, that is why we call it an all or none basis. And here comes the database concept of transaction, which means an entire piece of work defined, and atomicity, that is it is either done completely or it is not done at all. You cannot divide that into two parts, that is why it is called as atomicity. It is a very important concept of database. Then we go to another issue, again you are talking about a computer crashing. Will the data that you have stored still be present? Will it be uncorrupted? And what happens to a transaction in progress? So, what we want is, if the transaction is in progress, we do not want, remember the transaction is working on the database, but we want the old data to be safely accessible and only until the latest commit. So, whatever the latest commit is, so when you commit, the database should be in that state till the next commit. So, here comes the concepts of database concept of data durability and recovery. Comes the next issue, you have two computers in your household. So, how can the data be shared? One way of doing it is copy the database in a floppy and give it, but then you have multiple versions, and let us assume that the database is shared somehow. Now, what happens if one person is merging the household and another person is splitting the household? Now, what is the consistent state of the database? What is the meaning of having meaningful results? This is a major problem. So, sharing, how you have consistent operations of the database in spite of sharing. So, a common policy is transactions are atomic, that is if one person is doing the transaction, other person cannot do the transaction simultaneously, though the illusion is given that it is simultaneous. They appear to run one after the other in some order. So, the database concept associated with this is transaction isolation, that means once when a transaction is occurring, another user cannot poke his nose in. And concurrency control, concurrent operation, how you do, some things can be done concurrently, that can be done, but certain things cannot be done. And then transaction serializability, that is what transaction can be done one after the other, what can be done simultaneously. So, these are issues that database management system tackles. Next is you want to add, instead of having only these data, you want to add photos, you want to add sound, and you want to add video clips, what do you do about this? This is an important multimedia database concept. So, clearly ability to capture, store and play new data, logical integration with the existing data, and you want to query like a simple query, it is a simple query, but all photos with a green vase, you must be able to query the media also. What do you mean by media here is video, audio and so on. So, the database concept associated here is multimedia data, we have to handle multimedia data, and the other is query by concept. Now, to summarize all the issues which we discussed in the last lesson and also in this lesson is some of the problems of file based system are there are no standards, there is data duplication, there is data dependence, they are not independent, no way to generate complex queries, there is no query language or anything of that sort, and no provision for concurrency, security, reliability and so on. So, these are issues that we in some way defined as issues in the previous 11 issues that we spoke about. Now, let us go into the definition of what is meant by a database and what is meant by a database management system. So, first of all, what is the meaning of a database approach? So, the idea is that organization must have access to operational data. When we talk about database management system, it is just not for storing data and keeping it somewhere. We are going to keep on accessing the database, changing the database, updating, deleting, adding and so on. So, that is why it is called as operational data. It should be accurate, that is it should be timely and convenient, it should be up to date, it should be correct, it should be up to date and it should be secure. There should be security, at the same time it should be available, that is not anyone can come and change the bank database. So, as control decentralizes in an organization, there is a danger that data management also decentralizes and their security, consistency, all these the issues come into the picture. Before we go further, let us define what is meant by a database. Now, these are some definitions available in dictionaries for what is a database. A set of information held in a computer. This is a very simplified definition, does not give you any view of what exactly a database is. One or more large structured, now you are bringing that organization structure, sets of persistent data usually associated with software to update and query the data, slightly more detailed. The next definition is from dictionary.com, a collection of data arranged for ease and speed of search and retrieval. So, the basic idea why we want database management system is to search and retrieve data conveniently at the click of a button. So, from all this definition it is clear that database is a collection of data and normally this information is, it is not information gathered from different places, it is all connected information typically about an enterprise, or it could be about a bank, it could be about a university and so on. And database management system, what is that? It manages this database, it manages this collection of interrelated data, it has got a set of programs to access the data and it is a software that actually controls this information. So, normally a database management system contains information about a particular enterprise. So, a definition of a database, now we can change it a little bit. A database, this is the technical definition of a database. A database is a collection of interrelated computer files whose data contents and structure are described in a data dictionary. We will come to what this data dictionary is later, and which is under the control of a database management system. So, this database is managed by a database management system. So, now this data that we are talking about, this can be integrated or it can be shared. What is the meaning of integrated? The database can be regarded as a unification of several otherwise distinct data files. So, you will have lot of data files, you want to have a unification of all this. So, integration is an important part. If you have isolated data files, then there is no point in calling it a database, and it has to be shared, which means that several different users will be sharing this database for different purposes, and also that some parts of the data should be secure from should not be accessible or should not be viewed by other people. So, those ideas has to be taken into consideration. The shared causes some problems, integration not problems, some issues that have to be tackled. So, let us look at some typical database management applications. One is banking. All transactions of a banking today are handled by databases. Airlines, reservations and schedules. Schedules are just retrieval information, while reservation change the database, they update the database, it has to decrease the number of seats available and show the seats available and so on. Universities for registration of students and grades, and sales, customers, products, purchases are normally considered as stored as databases. Online retailers, order tracking, customized recommendations, all these are applications. Manufacturing, production, inventory, orders, supply chain. human resources, employee records, salaries, tax deductions. So, if you look at any of these applications, all databases touch all aspects of our lives, and we will see as we go along this course, we will be taking databases examples from all these, many of these areas. University is typical, bank is typical, production, manufacturing, and so on, human resources. So, all these are tackled by databases. So, this is an example of a database where we have customers, employees, order details, orders, products, shippers, suppliers. This is typical manufacturing database, and this is a simple table. This is we looked at a number of datas, and we are looking at one of the tables. All these are databases, data tables, and we are looking at one data table called the product table. Here it has a product ID. Like there we had an address and a name. Here we have a product number, product name, supplier, category, quantity per unit, and so on. You can have lots of fields or lot of information associated with the product table. So, before we go further, let us look at some of the popular database management systems available. First, we will look at commercial off the shelf database systems, which are called as COTS, Oracle, IBM DB2, SQL Server Microsoft, Sybase, Informix, Access, and so on. In this, Oracle is used extensively, IBM DB2 especially for mainframe, SQL Server is used for commercial, Access we use, and so on. Nowadays, there are two open source database management system also available, MySQL and PostgreSQL, and MySQL is very popularly used in many universities for managing and doing work. So, now let us again come to what is the meaning of a database. So, a database system consists of data, software, hardware, users, and so on. So, you can't have a database unless you have data, you have software, you have hardware, and you have users. But when we talk about a database management course, we concentrate mainly on the software, a little bit on the hardware aspects or how it is physically stored. We will come into that later, but basically we are talking about the software. So, first let us look at the database system, the data part of the database system. So, it may first of all it may support single or many users. In today's world, there is no question of a database being built for one person. It is normally supports many users, and there are many users in the organization. So, data should be integrated and shared. So, again we have spoken about this integration. The database can be regarded as a unification and the shared. So, here as far as the database is concerned, for the different users, it should provide a unified view. At the same time, this data should be shared. So, as far as the data is concerned, these are the two aspects, and different users may have different views about the same data. What is the meaning of views? It is not the English meaning of view. The meaning of view is that certain parts of the data alone may be visible to certain users. It is not that all users will see all tables and all data. That is not how database management system operates. So, these different portions of the database that are available to different users are called as views. Okay. So, we have started with what is a database management system in general. We have looked at some typical applications of database management system, and we have looked at certain components of a database system where data was the first important part which we just looked. Before we go further, let us take a small break. Welcome back after the break. So, before the break we have spoken about what a database is. It consists of basically 4 components. At one perspective, it consists of 4 components: data, hardware, software, and users. And here we are basically going to talk about only the software in a database management course. So, first we saw what a data was. Now, we will look at hardware. Now, any database has to be stored physically somewhere, and it is basically stored in the secondary storage on the disk, and you need to have direct access to some portion of the database, and you need rapid information input output, and some of the data is brought into the main memory and it has to be operated from the main memory. So, what has to be put in the secondary memory, how it should be organized, how you want to organize it such that you have faster access, what block organization you should do, what should be brought into main memory, these are some issues we will be tackling later on. But it is basically stored in the physical memory, both in the main, some portions in the main memory and some portions in the secondary memory. Then we come to the important part of the database management system. This is the software. It has the database manager, the database server, the database management system, and the DBMS actually provided by a specific vendor. So, these are some of the software available and associated with the database management system. So, the database management system or DBMS in short may have the following, but it is not actually a part of the database management system. It may have application development tools, it may have application software, it may have TP monitor, it may have a report writer, it may have additional system utilities, but this is not the core part of a database management system. The software that these softwares are not the core part. So, what is a database? Again, let us come back to a more technical definition. It is a collection of persistent data, that is the data that exists and it is recorded and physically stored. It is a collection of true propositions. So, whatever you put in a database is supposed to be true. I mean, you do not put things in the database that is not true for that particular organization. It is made up of entities. Entities you can talk about as concepts, we will be going into entities in detail later on, relationships and properties. I will just give you an example of what you mean by entity. A student can be an entity and a course can be an entity. The student undergoes the course can be the relation, undergoes can be the relation, and the properties can be the student's name, his address, and the course, its name and its code number and so on. And basically a database implements a data model. Again we will come to what is data model later on. Another viewpoint of a database management system, it is nothing but a record keeping system, a record keeping which we used to do with big files in big storerooms. Now it is computerized. It supports operation that can add or delete files to the database. From the overall viewpoint, you can add and delete files, you can insert, retrieve, remove or change data in the database, and I already seen it consists of these 4 components. So, what is the meaning of persistence? So, it is not that today I store the information, tomorrow I remove it, then it is not, you do not need to have a database. So, stores enterprise information over time and it outlasts the running of a computer program. So, you run the database management system, the data is there, tomorrow you come 1 month later on you come and do not touch it till then, you run the database management system, still the data should be there. So, the data's time exceeds the computer program time. It does not as soon as you switch off the computer it does not last, and it is update and retrieve in an operational way, and it offers decision support via data warehousing. This is different concepts altogether. Now, what is in a database? I already told you it is entities and relationships. So, entity can be a person, it can be a place, it can be an event, or it can be a thing. Anything that we want to store information about, that can be an entity. Relationship is a connection between entities about which we want to store information, and in a way a relationship can be considered as a special case of entity. I will come to what I mean by this later on. And properties, entity can have properties. Properties are characteristics of an entity and it can be simple or complex. Properties, like I told you, for a person it can be his name, for a subject it can be its name, for a part of a component of a machine it can be the number, and it can have a name, it can have a dimension and so on, color, you can have any of these properties. It depends on what you want for that application. Please note, a database management system is designed with an application in mind. Okay. So, what are some of the advantages of using database management system? So, all application access a common database, all application associated with that data. So, details related to data storage and access are removed from programmers and users. Users or programmers do not have to know any of that. So, there is less redundancy, less risk of inconsistency, there is a maintenance of data integrity, application of access restrictions, you can have access restrictions for some users, and it balances between different requirements, and there is data independence. So, these are some of the advantages of using a database management system. Now, before we go further, we have to look at a very important concept in a database. This is called the 3-level architecture. So, this 3 level architecture it did not come in a single day, it was sort of standardized as time went on. So, this was done by ANSI, which is the American National Standards Institute, and along with SPARC, a Standards Planning and Requirements Committee, and in 1975 they proposed a framework for databases. So, up to 1975 there was no standard available. In 1975 they proposed a framework. So, this is the 3 level architecture, that is what they proposed, and it consists of 3 levels: the internal level for system designers, the conceptual level for database designers and administrators, and the external level for database users. We will be looking at each of these levels a little bit, and then we will be concentrating on some of these levels in detail. So, this is the view of the data. The data in basically, now please note the core of the database is again the data. So, data is stored at 3 levels: the physical level, which we call here as internal level, the logical level, which is also called as conceptual level, and the view level, which is also called as external level. So, you have physical level or internal level, logical level or conceptual level, and view level or external level. So, these are the 3 levels. So, let us go into each of these levels one by one. One is the internal schema or the physical level. This internal schema describes the data as it is physically stored. So, how is the data physically stored? This description of how the data is physically stored is given by the internal schema or the internal level. So, for example, it talks about the record structure, it talks about the types of fields in a record, and it talks about the existence of primary and secondary indexes. So, what actually is stored, that is given by the internal schema. So, this is also called as the physical or internal level. So, it deals with the physical storage of data like structure of records as already discussed, files, pages, blocks. I am going a little bit more in detail to the actual physical storage, how you are dividing the data into blocks and how these blocks are, whether the blocks are available in the main memory or the secondary memory, how you are, what are the indexes, how do you choose the indexes. The choice of indexes, the indexes is how it is how the data is ordered, the records of a database are ordered, and it also affects the speed in which you search for data. So, if you do not choose a proper index, you can land up with having a poor efficiency and ordering of records based on this index, and it is used by database system programmers. So, this is a lot to do with the physical storage of data, and the internal schema can be given as record, employee, length equal to 44, header byte 5. So, all these sizes are all specific, offset how much and all, actually how it is stored in the physical memory. Next, you have the conceptual schema. So, the representation of the logical structure of the information content of the database is called as conceptual schema, and it abstracts away from the actual physical storage. So, once I know the conceptual schema, the conceptual schema part of my database design I need not know anything about the physical storage. So, the physical storage is isolated from the conceptual schema, and this actually stores the information content, and in a sense it is a composite of all the external schema. So, deals with the organization of the data as a whole, and it has abstractions, and those are used to remove the unnecessary details of the internal level. So, the internal level has all the records, the size and things like that. These things are hidden from the conceptual level, and this is used by the database administrators and the application programmers. So, this is the one that is actually used, and the database administration job is actually to define these conceptual schema. The design of the conceptual schema again depends on the application to which you are going to use the database, and the efficiency and the effectiveness of the database management application depends a lot on how you design your conceptual schema. So, an example of a conceptual schema, this example is given using SQL. You do not bother about the syntax here. So, here we are creating a table called employee, where you have name and you are given a type. What is the domain of the name can be of this type. It is a domain from which name is chosen, salary, real, and department name. So, you have name, salary and department name, and the name of the table is employee, and it also tells you what is the type of values that this name can take, this salary can take, and this department name can take. So, this is a typical conceptual schema. It does not bother anything about where this is stored in the physical memory. That is why it is called as logical or conceptual level. And now before we go further, let us look at what we mean by schemas and instances. Now when we talk about a database, we talk about a database schema and we talk about a database instance. So the schema is actually the conceptual schema. It is the overall design of the database. It describes the data contents, the structure and some other aspects of the database, and it is called as the intention of the database. So actually now here we have just defined employee which has 3 fields, name, salary and department name. We have not given a single record of an employee there. So this is called the schema. Okay, and it is called as the intention of the database. Not only the schema, it gives some more additional details which we will talk about in detail when we talk about conceptual schema. The instance is the collection of data actually stored in the database at a particular time, and it is called the extension of the database. So for example, in the previous example you had the employee table can have Ram say 15,000 computer science, Krishnan 20,000 mechanical and so on. So those can be your instances of the schema. So that is called the extension of the database. And finally you have the view or the external level. Remember we had 3 levels, one was the physical level, next was the logical level and third was the view level. The other way of talking about it is the internal level, the conceptual level and the external level. So this provides a view of the database tailored to a user. So this is for a particular user, he sees only this part of the database. Remember a large database like for example a banking database, you may have bank to bank transactions, one part of the database will be visible only to those type of users or applications. Bank to customer directly, only one part of the database will be available. Bank or manager, some part of the database will be available and so on. So parts of the data may be hidden, that is very important here, and data is presented in a useful form, that is whatever form that particular user wants it will be tailored to that. This is the part of the database that is actually interacting with the end users and the application programmers. So the external schemas can be payroll, string name, double salary, that is name and salary of payroll, and personal like this. This part is actually a part of a major database. This part alone is available to this particular users. Since we have the 3 level architecture that we have seen, this brings about the concept of data independence. So different users, first we will look at the external schema. The different users often need different views. Remember the views that we are talking about here is not the English view. This means a certain portion of the database has been extracted out and only that portion is visible, or that is the view of the database that particular user sees, that is the meaning of view. So a bursar in an organization needs to have access to financial information about a student, while the head of the department needs to access only the academic information, but you will have a student database that contains all these details. So an external schema is a description of part of the database as seen by an application programmer or a user. So now I started with the concept called data independence. So what is data independence? Higher level should be immune to changes at the lower level, that is the meaning of data independence. So if I make some changes in the physical level, that should not affect whatever I have described in the conceptual or the logical level, and if I make some changes in this, that should not affect the view. So in general the interfaces between the various levels and components should be well defined, so well defined that any changes in some of these parts should not influence the others, that is the meaning of data independence. So we have different types of data independence as far as database management system is concerned. First is the physical data independence. So the meaning of this is obviously between the physical, remember there are 3 layers, if you remember you have 3 layers, these 3 layers. So physical independence is the independence between these 2 levels, okay, that is what we mean by physical independence. So the ability to modify the physical schema, changes in record structure indexes without changing the logical schema. So even if you make, you should not change the logical schema, because application actually depend on the logical schema. The next is the logical data independence. This is between the logical level and the view level. Changes at the conceptual schema like addition of further fields should not affect what applications and views is already running. So this is the basic thing that we have seen here. What we have looked at is, we have taken some issues and we have spoken about what is some of the issues we have continued. We have looked at what is a database management system from one viewpoint, very surface level definition of what is a database management system. We have looked at some advantages, and we have looked at basically the 3 level architecture of a database management system. Here I want you to list 4 significant differences between a file processing system and a database management system, and I want you to discuss 5 responsibilities of a database management system, and for each responsibility what are the problems that arise if the responsibility was not discharged by the database management system, and I want you to list some advantages of database management system, and then I want you to discuss the 3 levels of a database management system. Okay, thank you.